You can follow me on Twitter. Super easy to remember. DG Lover as a way to remember. I'm based in Sydney, Australia, and I'm a cloud developer advocate. Now, this session here is going to be around AI-powered anomaly detection for IoT. Now, this session builds on a service, a cognitive service in Azure called Anomaly Detection API Service. It comes in two forms. There's what's called Univariate, and Multivariate. And I'm going to kind of go through this scenario and just kind of talk a bit about where you might use those services. Now, because this is an IoT, it's got an IoT spin to it as well. It's also an intelligent edge. So we're running AI on a device. I'm going to show you the device that I'm using shortly. And I'm using AI in the cloud, and they both have their place. And what this is about is just kind of talking about where you might use machine learning on the edge and where you might use machine learning in the cloud. And that's kind of what the guts of the session is about. So we're going to talk a bit about Azure Anomaly Detection. We've got some demos. I've got a real life hardware demo, and I've got some Jupyter Notebooks demos as well, just to kind of give you a sense of how this stuff works and resources and things like that. Okay, so there are kind of a couple of key scenarios for anomaly detection in general. And they could be things like AI, AI for IoT ops, so for IT ops. It could be, for example, you might want to look at unusual CPU spikes that are happening on your network. You might want to look at unusual data spikes on your network. Certainly in Australia, there's been a couple of recent attacks on data. And maybe those are the kinds of things you could look, well, this is kind of an unusual spike for data that's been drawn out of some business backend systems. So AIOps is a big scenario for this. You could also be looking at things like revenue. What's our revenue looking at? Is there a change in that revenue that maybe that we're not spotting, but anomaly detection could be spotting and understanding, well, actually this revenue trend is a bit out of the ordinary, and it's something that we could be looking at. Now, the thing that I'm going to be talking about more in this session here is really going to be around predictive maintenance for machinery. And you think about it, across our lives, we deal day to day with machinery. So the example I'm going to be using is really what we call an HVAC system. So it's a heating, ventilation, air conditioning system. That's what the demo is going to be about. Excuse me. But it could be the washing machine, it could be a fridge, it could be something in your business, a lathe, a bit of equipment that you might have inside your business, where early signs of being able to detect early signs of an anomaly can help with predicting what's going to happen with that device. And of course, if you can predict what's going to happen, then you can tend to be able to fix it, maybe at a downtime when that system is not vital to the operation of the business, so that you can have better continuity of business, happier customers if you're maintaining a product out there that customers are using. Those are the kinds of scenarios where you can use predictive maintenance. Excuse me. Okay, so that's kind of the scenarios. So we're going to talk about univariate anomaly detection, and kind of almost by definition, it's a singular, typically a singular feature, time series data, singular feature. And then we're also going to look at multivariate. And this is the scenario where we've got time series data, but we've got multiple data, we've got multiple features that we want to be able to look at and understand the correlation between those data items. So it could be around temperature. If I've got an HVAC system, it could be around temperature, humidity, and the state of the HVAC system. Is it operating correctly? And you can say, well, those will have a correlation. So they've got time series with effectively multiple features within that data set. Okay, so the first thing I want to talk about is kind of univariate detection and where you might use that. And so So this, as I said, it's a cognitive service. Now, I've already kind of mentioned this, where you can use Univariate for things like detecting anomalies in time series data with a single feature. So it could be a CPU spike, it could be a temperature spike, it could be a revenue spike or a dip or whatever it might be. And you can use this, and you can basically stream this data or batch this data into the anomaly detection service and understand if there are anomalies. Now, the beauty of Univariate is, one, you don't have to be a machine learning expert to be able to use this. But secondly, you don't have to train a model. So a model, as the data is flowing into the system, um, the data has been analyzed, and then basically we are in kind of real time determining the best model, the best machine learning model to apply to this data series as it's flowing through, and then look at the next data point and say, is this an anomaly? We can kind of make detections like that. So the beauty of it is, as I said, you don't have to go and train up this model. It looks at historic data as it's flowing through the system and says, well, actually, that last one is an anomaly, and you'll kind of get, oh, this is an anomaly, and this is the expected data range, and this is the anomaly, and this is maybe the beginning of an issue that you might want to look at. So those are that's the kind of example of an use where you might use univariate. Okay, so as I mentioned before, this is kind of going to have a bit of an IoT spin on this. And if you're not familiar with IoT, you'll be familiar with this kind of, you've got sensors around your house or in your business or in your factory. And we typically call those, in this case, those are things, and they're connected to the internet, and they generate data. And that data would be passed into the cloud, and then we can build insights on that data. And then typically what we want to be able to do is base actions on those insights. It could be something like, hey, look, we think the temperature in the room is going up, so we want to turn on the air conditioning. Or it could be something like that. Or maybe a machine is vibrating out of spec, and maybe we want to turn that machine. So maybe you've got a factory with a lathe in it, and that lathe is spinning really quickly, and you've detected an anomaly with it, and you want to shut it down before there's any damage. So that's the kind of idea behind IoT. If you're not familiar with it, things generate data, you've got insights built on that data, and actions based on the insights. And this is just kind of a bit of a way that things flow through systems. I'm just going to talk a bit about this. Now, some of this is quite generic, and some of it has a bit of an Azure spin on it as well. But the stuff that we'll talk about Azure, they are just kind of standard components you would expect in an IoT solution. So in the heart of this solution is in the middle here. If you think about it, it's an HVAC system. And what I've got a device on here. It's called an Azure Sphere. Now, it's from Microsoft, and I won't go into too much detail other than to say it's built for highly secure devices for IoT scenarios. So it's got a certified chip on it, secure operating system, and secure cloud services. And together that kind of builds out a secure device. But the interesting thing about this, well, there's two interesting things about this. The first of all, that device is connected to the cloud. And secondly, that device is also running a machine learning model. Now, the way that I generated that machine learning model was I used something called Edge and Pulse. Now, Edge and Pulse is a third-party service, which is a service which is predominantly focused on developers who are building embedded systems or IoT systems. So they specialize in building machine learning models for small devices, small low-powered devices. And I'm going to show you very briefly about that. But essentially what you can do is you can stream data from a device up into their service, label it, and then you run some training models on it, and then ultimately it generates your model, which you can then deploy onto a device. So that's kind of what's going on there. I'm using something called IoT Central. It's acting as an IoT hub or a gateway for these devices to be able to connect up to, and it provides bidirectional services for messages. And then what I'm going to be doing from IoT Central is I'm going to be exporting that data. So you can imagine I've got lots of these devices all streaming data up into IoT Central. And then what I'm going to be doing is consolidating that data through IoT Central, then exporting it. And I export it into warm paths and cold paths. Warm paths are great for more interactive reports. Cold paths can be used for things like training machine learning models. In this case, I could be using it to train up an Azure anomaly detection service. Now, I did say just a moment ago that Univariate doesn't require training, but Multivariate does. So this is where you could be gathering your data and then ultimately using that data to train up a model. In this case here, I've got Jupyter notebooks to be able to go and analyze that data. But what I'd really do is I'd integrate that anomaly detection service probably into a business service, into my business process. And my business process say, oh, that's interesting. There's been anomaly detection. I could log it into tracking systems. And then maybe I even want to close the loop and say, well, actually, I probably should shut this device down. And you could send a message from some level of business integration, send a message to IT Central, hey, look, and then shut down the device. So that's kind of this overall loop about how these things hang together. So hopefully that's clear about how the solution is working. So I've got AI or machine learning running on the edge in the form of TinyML models that are generated from Edge Impulse. And I've got cloud-based machine learning models in the form of anomaly detection service, which is looking at the aggregate view or the holistic view of the data that's coming through and being able to make some smart decisions about maybe there is an issue with these systems. Okay, so the demo that I've got here is I've got a device and I've got this on my desk and I'll show you this in a moment. But it's my kind of prototype HVAC system. It's got a temperature, it's got a CO2 sensor and things like that. And as I mentioned, it's based on Azure Sphere. And if I bring up my camera, where are you? Okay, so I've got on the desktop here my device, and as you can see, I've got a fan connected to this thing. And what I'm going to do, so this is running an Azure Sphere chip. It doesn't have to be an Azure Sphere chip, by the way. This could be a Raspberry Pi or could be an STM microchip or whatever it is. Edge Impulse support really the vast majority of microcontrollers that are out there in the marketplace. Now, what I'm going to do, if you just look at where I'm pointing the pen, what I'm going to do now is that this model that's running on this device has been trained with multiple gestures. And what I'm going to do is just pick up the device and I'm just going to shake it. And what this is going to do is it's going to simulate a rattle. And you can imagine that a bearing has broken in an HVAC system. And what you want that to do is you want it to shut down that motor, because if the motor keeps going, then that might be damaging. In fact, I've got another demo where I actually spin up a failover motor, but for this demo, it's a bit simpler. And then you would come out and obviously repair the main fan, and then you would go and fix it. And in this case, we'd just go and reset that and we'd be back up and running. So again, multiple gestures, and this machine learning model that's running on this device, I just go and do a multiple different gesture. Now, the shake always works. Hey, there we go. Okay, so what's happening there is that this data is now going up into IoT Central. And you can see, so this is IoT Central. So IoT Central is a cloud-based system. And it's basically the telemetry that's coming from this device is being shipped up into IoT Central. And you can see it's a way in which you can kind of display your data, and you can also export your data. Now, as you can see that when this device, the last fault prediction for this device was rattle. In fact, if I go and press the button on my on the device again, in a moment we should see that go back to normal fault detection. But what happens is that when there's a rattle, there's a spike in the temperature. Now, this is a bit, I have to confess that when I detect a rattle, I spike the temperature and humidity, but really there would really work the other way, that you'd have a spike. The scenario is more about there'd be a spike in temperature or humidity, and that would cause a malfunction in the engine. So that's kind of how that would work. And as you can see, the temperature and the pressure is coming down now. So that's kind of what's going on there. Now, the way that I'm getting data out of the system is I have what are called exports. And these exports, I can define some criteria for them. And ultimately, I can set up a destination. And the destination here is called workspaces. And if I come back to over here, I can go to workspaces, look at my workspaces, And what this is doing is that this is sending data into just an Azure blob storage. That's just where that data is going. Just going out as JSON into blob storage, and I'm going to use that data for anomaly detection. Okay, so now we'll just go back to the slides. Right, so that's kind of what this demo is doing. So we got that. So I want to show you that there's a device there, and then ultimately we're going to be getting some detection of anomalies. Okay, so what I want to show now is just a bit about how that data, so we've got that data from the device, we're detecting, we're running machine learning models on that device, detecting anomalies with the motor. We're looking out for rattles or different things that might be different movements that might be generated by that motor, of which we could then use obviously to be smarter about our predictive maintenance. So the next thing I want to talk about, or just show, is I've just got some very simple Jupyter notebooks loaded up. The first one, and I'm not going to go through this, by the way, all these Jupyter notebooks live on my GitHub, and in the back end of this session, there's a set of resources, and you can go through them. There's notes about how to get all this up and running. There's a reasonable amount of code in there, and it's not the most interesting code to look at. I guess the most interesting thing about this here, detect, what that's doing is pushing up a batch of sample data, in this case, to the Azure Anomaly Detection, and then I get back a set of JSON data, which I then go and look at. And so this is just the data that's coming back. In fact, this is the data that's going up. And then ultimately, and I know this is a bit smoke and mirrors, but this really does work. You can go and try it out yourself. What I get back is, in this case, I've charted the data. And you can see the little orange dots, they kind of represent the anomalies in this data set. Now, this is being charted. Now, of course, normally what you would do, rather than visualizing it's great, but what you'd really do is you'd really plug in the anomaly detection service into a back-end business process, and then you would automate something. So that's really what you would do. But obviously that's not so visual. This is kind of visual, so you can kind of get a bit of a sense of what is going on. But as I said, all the code for the sample is up on my GitHub, which I've got a link to at the back end of the session. Okay, so that's kind of what's going on with Univariate. So remember, Univariate, you don't need to train a model. As the data comes through, it's building the model in real time, and it's looking out for anomalies. Is this last data item an anomaly? Alrighty, just go back to my slides. Okay, so this next thing I want to talk about is multivariate anomaly detection. And when might you use multivariate? So multivariate you use typically when you've got a lot of interrelated signals or sensors. So for example, you might have an oil rig, and you might have a whole lot of sensors on that oil rig that are looking at overall operation of that drilling and oil operation. Or you might have a smart building. And you can imagine in a smart building, there's a whole lot of sensors that are in there. People counter, for example. Are there people in this building? Is it after certain hours? What's the temperature in the office? Are the lights on? What's the CO2 levels like? Are there any other hazardous gases in the environment? So as you can imagine, there are a whole lot of signals that you might come out of a unit. So it could be out of a factory, a building, an oil rig. It could be out of your IT ops backend systems, a whole range of signals that all together correlate. And then what we're doing is we're looking at this correlation of this data, and then understanding is that that's interesting. This data is normally correlated like this. Now we're getting a spike in one of these areas, which is out of the normal of the operation. And of course, if you've got hundreds of sensors or hundreds of signals that are coming in from various parts of your business, detecting a particular signal and thinking, this signal here is out of sync, that can be like a really super hard, difficult thing to do. And this is where multivariate kind of comes into play, where it's able to look at all these signals together and understand what is going on. Okay, and there are a whole range of ways in which you can be dealing with it. I said we can get data from a whole range of different scenarios. We can pull data through from a whole range of different backend data stores, be it MySQL or blob storage or MongoDB or whatever it might be. We've got both batch systems and real-time system capabilities with this. You can go and build and train these machine learning models, and then ultimately you'll go and either visualize it and integrate it into back-end systems. So that's kind of what we're trying to achieve with this. Okay, so what I want to show now is just another quick demo. So we just go back to the camera. So we've got the device there. And this device, we're running a machine learning model on it. You think about this device and really all microcontrollers, they aren't capable of running large machine learning models. They're quite good at running quite focused, specific machine learning models. In this case, we're running this movement classification machine learning model. And what we've got on there is we've got an accelerometer on there, and we've got X, Y, Z, and then we're just looking at that. In fact, what I meant to show, and I forgot, the way that I got that data is I created a, so I'm inside Edge Impulse, and I can go create a new project, and we'll just go global AI, create a new project, and you'll see what they've got is they've got number of scenarios. They've got accelerometer data, audio data, so like for wake up words, image classification, things like that, but they're quite specific. So that's how the model was generated using Edge Impulse. So what I'm going to do is that there are a number of different elements, a number of different data that's coming off this device. I've got temperature, I've got air pressure, I've got humidity, and I've also got movement classification for what's going on this device. So I've got now a case where it would be now interesting to be able to look at this data in totality and understand if there's any anomalies, and looking at this more holistically. Okay, so this is kind of what this demo is about. So we've got this device here, it's generating some anomalies. So yeah, we've got so we'll jump across to my multivariate. And again, this demo and all the code for this lives on my GitHub, which I'll point to in a moment, because there's way too much code in here for you to look at. I'm just going to look at and scroll down here, and we're just going to look at the result of this. So what I had here is as I said, I'm running this machine learning model on the device, and this machine learning model is returning this prediction. Is the device rattling? Is it, I've got various things. Is there, I've got, I think it's called a wave. You can imagine as if the machines jump, if the HVAC is jumping up and down, is it rattling backwards or sideways? They have different characteristics, and the model has been trained for those. But I can also look at the humidity and the temperature. And the kind of the rationale behind this is you can start looking and think, well, that's interesting. I noticed that the temperature, the pressure, and maybe the number of people in this place, I'm now starting to see that there are issues with my HVAC system, and the motor that's driving this HVAC system is starting to play up, and it's starting to rattle, or it's not working within sync. And that's where you can start looking at this and thinking, I've got a correlation of data, which in a normal business as usual, you can kind of see through here, business as usual, but in these spikes, I've got some interesting kind of anomalies that are going on with my data. And that's kind of what we're looking at with Anomaly Multivariate, which is look at this kind of more holistic view of the data. So hopefully that makes sense. Okay, so kind of wrapping up. Right, so as I promised, there was a link to the resources. So we just move the camera around because I think they might be in front of it. So you might want to grab a screenshot of this. So the main one you want to look at down the bottom here is this link to my repo. So I'm glove boxes. So D Glover and glove box. So in this case, glove boxes, because I've got lots of repos. So that's where you find the demo. And yeah, So, and all the links. So grab a screenshot of that. You'll learn more about anomaly detection, IoT Central, Edge Impulse, Azure Sphere, and this demo as well. So thank you very much. And I think we're pretty much bang on 30 minutes. So
thank you, Dave, for the very interesting session. I think combining IoT with machine learning always creates quite a nice
yes.
project, and I think we'll see more and more of it in the following years of and business use cases.
I think it
definitely.
took you quite some time to build this demo, right?
Actually, this demo, maybe not as bad as you might think. If you think about obviously the cloud services, they are very much component pieces. So you kind of plug them together. So you're not having to spend an awful lot of time. As I mentioned before, the beauty of the cognitive services, of course, I can use machine learning without having to be a machine learning expert. The device itself, I have to confess, I've been doing IoT for a while, so the demo came together relatively quickly. But that's more because, look, I've been doing it for a while and I had the experiences, and it was relatively easy to bring that together. So, but yeah, it was interesting kind of project, and I like it because it is a real world project that people can use to just be a bit smarter about how they use their devices and think about their devices in their organizations or factories or homes or products that they sell.
All right.
Can we do one quick question from the audience? Yeah, there's one question. Sheikh is asking, which device is better for industrial IoT? Is that Hive MQ or ThinkSpeak as an edge device?
Oh gosh, which are good devices for industrial IoT devices? Yes. Yeah, okay. Look, I'm pretty a bit biased. So for one, if you were looking at industrial IoT, and particularly if you care about security, which I really do hope you do care about security, then you should be thinking about, you should at least look at Azure Sphere as a platform for your industrial IoT platforms. But also there are obviously platforms that are out there from the likes of ST Microsystems. They build out a lot of platforms, a lot of devices, and they have a big focus on industrial IoT scenarios. Now, interesting enough, we're also seeing a place for Raspberry Pi. So Raspberry Pi compute modules, they are also finding their way into industrial IoT scenarios. So I think some really super, my only hesitation about Raspberry Pi is that you need to do a lot of work around the security. That's not the sweet spot for where Raspberry Pi think about their product set, but there's certainly, you can obviously do a lot of the work yourself to make it more secure, but also a very valid option. But Azure Sphere should be absolutely in your shopping list. You should be looking at things like chips from STM Micro. There are various RTOSs that you can run on these devices for making it simpler to go and build these things. There's Azure RTOS and there's free RTOS, and you should be looking at those kinds of things. So yeah.
Okay, thank you for your answer. Great. Thanks a lot, Dave, for your session.
Okay, pleasure. And thanks so much, everybody, for tuning in.
Yes.
Thank you very much.
Bye-bye. Take care. Bye-bye.
Okay, so that was our first session.